Today we're going to talk about section 2.3. We'll start with example 1. And we're just going to be evaluating some limits. Okay, the first thing you want to do, as we talked about in the previous video, if you watched that, is just plug it in. If you plug it in, there's no issues with like dividing by 0 or anything weird like that, then you just plug it in. So we just do 2 to the 3. That's just 8. So the limit as x approaches 2 of x cubed is just 8. Next problem in this example, we're still approaching 2, but we get x cubed plus 5x plus 7. Once again, we can plug in a 2, get 2 cubed plus 5 times 2 plus 7. It's going to be 8 plus 10 plus 17, or 7, 18 plus 7, and that leaves us with 25. So once again, this limit is just 25. And the last one on this example, the limit as x approaches 2 of this function. Okay, if you notice, the inside right here is the same as this, so that's just going to go to 25, but it's still under a square root, and so we end up with 5. So, once again, if you can plug it in and there's no issues, always start there. Okay, now let's try example number 2. It's more of the same, but I think we're going to run into an issue. Okay, so this is just a left-handed limit on this one. Okay. So, what I'm going to do... Oh wait, that's just -1. That's not a left-handed limit. I don't know why I thought that. Okay, take it back. All we're going to try to just plug in a -1, see what happens. So, -1 plus 6, 2, -1 to the 4. I don't think there's any issues with this. The top just goes to a 5. -1 to the 4th is just 1. So that leaves us with 5 halves for that limit. Part B is asking us to evaluate this. So once again, just plug it in. I don't think there's going to be an issue, but we'll see. So 3 to the -1/4. 3 plus 5 to the 1/3. 3 to the -1/4 is like saying 1/3 to the 1/4. And this is like saying 8 to the 1/3. And 8 to the 1/3 is like saying the cube root of 8. So it's really just a 2. So now we have 1/3 to the 1/4 times 2, which is going to leave us just with, I'm going to come over here, 2/3 to the 1/4. You can plug it into a calculator or simplify it some other ways, but this is good enough to show what we need to see on this part. Okay, example 3, which is the last one, I think. Yeah. Show that the product law cannot be applied to this limit. If f of x and g of x are these functions. Okay. So if we were to plug those in, we would get the limit as x approaches 0 of x times x to the negative 1, and the limit as x approaches 0 of x over x is another way you can think of that, because x to the negative 1 means it comes down to the bottom. And so the limit as x approaches 0, that simplifies just to a 1, and so therefore the limit would just end up being a 1. Now, if we just try to plug in the limit, so if we look at limit as x approaches 0 of x to the negative 1, we see that if we go 1 over 0, essentially, because this is like 1 over x, that's going to approach infinity. Let me just kind of show you where I'm getting that. So if we do 1 divided by x, and we graph that, if we start approaching 0, we go negative infinity or we go positive infinity, depending on which direction. Those don't line up, so there's no limit, right? Now, we can't apply the product rule or the product law, which is just saying that if we have like a limit of something and we times it by a limit of another thing, it's the same as the two limits multiplied together. So let's like just look at like one that does work out. So if we just have like f of x equals x and g of x equals 5x. Because, let's see, so if we want to look at limit as x approaches 1 of f of x, g of x, we could just do the limit as x approaches 1 of f of x, and then the limit as x approaches 1 of g of x. So if we plug in 1 here, we end up with just 1. If we plug in 1 here, we end up with 5. If we do 1 times 5, the overall limit is 5. If we did it here, we'd say x times 5x, which is 5x squared. And now if we just plug in that 1, we get 5 times 1 squared, which is 5 times 1, which is just 5. The reason why this works is because this limit and this limit exist, but in the previous problem, the limit did not exist because it just went to infinity one way, went to negative infinity the other way. Okay? That's everything for this video. If you need additional help, please come to Math Lab. Until then, calculator.